Hi, everyone. Rather than just posting review questions, I'm going to go through the review questions. Obviously, they are posted in the last week of the class, but I'm going to verbally walk you through the questions. So I would do this in class normally and then send you on your way to study up and prepare for the final exam, which will be online next week. So let's go through the questions. Number one. Where in a plant are mobile and non-mobile nutrient deficiencies observed? So you should all know the answer to this because of your nutrient deficiency little projects. So mobile nutrient deficiencies are observed at the bottom of the plant because the nutrients are mobile, which means when the plant needs them, it will remove them from the lower leaves to the more important top of the plant where the new growth is. Where non-mobile nutrient deficiencies will be observed at the top of the plant because they're not mobile, which means the plant has to rely on whatever's coming up from the soil. It can't reallocate nutrients from other leaves. So non-mobile nutrient deficiencies are observed at the top of the plant. What is CEC and how does CEC in soil impact healthy plant growth? So if you remember, CEC stands for cation exchange capacity. And remember, that's essentially the amount of negative charges that's in your soil, which will attract positively charged nutrients. So what does that mean for healthy plant growth? Well, it means that if your soil has low cation exchange capacity, then it means it has a reduced capacity to store nutrients, which means your plant's growth will be limited. In the case of hydroponics, we don't rely on cation exchange capacity. You just have to have all the correct nutrients in the solution all the time. And as the plant uses them, you replace them. Whereas with soil with CEC, the soil will kind of absorb what you add and store it for future use if the plant doesn't need it all immediately. Number 3, what is biochar and what soils is it suited for? So remember, biochar is wood fiber that has been combusted in a low oxygen environment to form basically charcoal. Biochar and charcoal essentially add CEC to your soil, so they increase the capacity of the soil to hold nutrients. We discussed in class how adding biochar to depleted soils is a good thing. So depleted would be old, highly weathered, really well leached soils that we see in tropical countries where they have lots of rain. Because the soil is washed all the time, a lot of the soil is broken down and there's fewer negative charges to hold on to nutrients. So adding biochar helps remediate that soil. Now, if you add biochar to soil that already has good cation exchange capacity, you make it more difficult for the roots to compete for the nutrients because the biochar is going to try to snap up nutrients in addition to the soil, making the nutrients maybe a little bit more difficult to exchange for with the roots. So it ties up nutrients. So it's not a good thing to add biochar all the time. You just need to know that your soil has poor cation exchange capacity, and then it might make sense. For example, a sandy soil. Oh, look at that. The computer has got notes for me. What is base saturation? So going back to cation exchange capacity, imagine your soil has all these negative charges that are attracting positively charged nutrients. A base saturation is a snapshot of what nutrients happen to be stuck to the negative charges that are available in your soil. So let's say out of 100% of your negative charge, 25% is occupied by potassium. Then your base saturation would be 20% potassium. So base saturation tells the farmer what nutrients are currently in the soil, and then they can be more intelligent about what they add to the soil to make up for what the plant might need for the coming season. All right, 5. What are key differences between organic and inorganic fertilizers? So right off the bat, we've talked about this lots, but let's review it. Inorganic fertilizers are immediately available to plants because plants only absorb inorganic molecules like potassium and calcium and nitrate, whereas organic fertilizers are complex tissues and material that has yet to be decomposed. So essentially an organic fertilizer is added to the soil, and then you need to have mineralizers, so bacteria, protozoa, worms, whatever organisms you can get your hands on to break that material down into the nutrients that plants can use, like potassium, calcium, and nitrate. So there's a time delay, and we also need to have organic life in the soil for organic fertilizers to work, whereas inorganic fertilizers are immediately available. Organic fertilizers are equivalent to a slow release, which means that they will release the nutrients over time, where inorganic fertilizers, unless they're chemically bound, are immediately available, which means if you feed them in excess, they can leach away and pollute waters. So that's one of the downsides of inorganic fertilizers. How could you raise soil pH? Well, we've talked about this. Wow, this is going to keep popping up. That's very annoying. How can you raise soil pH? Well, remember we talked about adding lime. I've got another question coming down later, so I'm going to leave some of that away. But adding lime, right, calcium phosphate, will absorb protons or acid-like atoms. So a free proton is basically your acid, and it gets consumed by the calcium carbonate, and calcium carbonate is absorbing the proton and converting it to carbon dioxide and water. So that's why farmers add lime to soil if they need to raise the pH, if it's a little too acidic. That's not always the case. Number 7, how will withholding phosphorus alter the growth of a plant? If you remember from your nutrient deficiency work, phosphorus, if it's withheld from a plant, makes it kind of go a little bit purple. That's kind of later in stages, but early on, withholding phosphorus causes a plant to be short, so it makes it compact. And a lot of ornamental growers rely on this phenomenon to keep their plants from getting too tall and skinny. So they sort of dole out the phosphorus just carefully to keep the plant compact. How does pH influence nutrient deficiency and toxicity? Give examples. Well, a really good example is iron, right? So typically micronutrients are more available as the soil becomes acidic, and macronutrients are more available as the soil becomes basic. That's a generalization, but it's for the most part true. So if we lower the pH, our micronutrients become available. If we go too far and make it really acidic, some micronutrients become toxic. So even if you have the same amount of nutrient present, it may become so available that the plant can't control it and it takes up too much. We didn't talk about this in class, but I'll give you a really good example of a modern day herbicide. It is one that uses iron chelate. You spray it on your lawn, and as it turns out, monocots are less efficient at taking up iron as dicots. So a lot of weeds are dicots, and so they take up the iron to toxic levels and die, whereas the grass, which is inefficient and slightly more tolerant, doesn't die. In fact, it gets a little bit greener. You have to be careful with this particular herbicide, because if you continually add the herbicide, your iron levels will accumulate in your soil, and eventually the grass succumbs to the toxicity as well. Does it mean that iron is toxic? No, it just means that you're adding more to the soil than the plants care to see. Is CEC applicable to hydroponics? We talked about this earlier up, right? So in hydroponics, we just dangle the roots in a liquid, so there's no soil, which means that cation exchange capacity is irrelevant. So we have to apply all the nutrients as needed. What does an EC meter measure, and how is it useful to a farmer? An EC stands for an electrical conductivity meter. Remember, we talked about how it measures the total salts that are in solution. So a farmer can determine how salty his soil is, or her soil. So the idea is that EC measures the total amount of nutrients that are in the soil. Not all nutrients, some are not so good, things like chloride and sodium. But at the end of the day, the majority that the EC measures is sort of a snapshot of all the nutrients. It doesn't tell the farmer what is in there, just how much. So it's a good baseline. You still have to send your soil away for base saturation and analysis to see what exactly is there. Calculate the amount of 2820 that you need to put in 150 liters of water to make a 200 ppm solution. This is a pretty straightforward one because we've given you the number here, right? So it's 1 gram per liter will produce 200 ppm. Well, we're having 150 liters, so really it's just 150 times 1 gram, 150 grams in 150 liters makes a 200 ppm solution. That was a simple one. Not sure if we'll have anything more complicated than that on the final exam. All right, a bag of 15-318 contains what percentage of phosphorus? 3%, right? The middle number. Nitrogen is the first one, 15%. 3% is phosphorus, and then 18% is potassium. If there was 2 more numbers, the next number would be calcium, and then the next number would be magnesium. Just a little FYI there. What must happen to organic fertilizers for them to be useful to a plant? All right, we discussed this further up, but let's elaborate. We know they need to be mineralized. That's the key word we're looking for, mineralization, right? So bacteria, protozoa, larger animals need to break down those organic fertilizers to convert them into the nutrients that plants need. Knowing that, how do cold, wet periods or hot, dry periods affect this process? So cold means reduced biological activity, which means it's going to slow down the process of mineralization. Wet means there's less oxygen, which means there's a risk that bacteria will convert the nitrogen into nitrogen gas and we lose it by denitrification. So cold and wet is not good. Often if you're looking at fields in the spring where there's cool, wet spots, the plants look yellow for a couple of reasons. Water holds heat or takes longer to heat up, which means wet soil will stay colder longer, which means the nutrients will take longer to be available in those spots. Plus, if they're really wet, we get anaerobic conditions and we lose nitrogen. What about hot, dry periods? So hot's fine. I suppose that accelerates biological activity, but at the end of the day, we do need water for organisms to survive. And so if it's dry, the bacteria will die and sporulate and wait for a better time. And so you get very low mineralization rates. And so your plants will suffer as well. But not having water has other impacts on your plants as well, right? Not just the soil. What is micronutrient toxicity and what are 2 potential causes? So again, I alluded to this with the iron herbicide. Micronutrient toxicity is when micronutrients are oversupplied or your soil pH is incorrect. Those are the 2 answers. 1, you've oversupplied it, or 2, the pH is incorrect and it's overly available. So in the case of acid, the soil is too acidic and suddenly the iron becomes overly available. How do organic fertilizers improve soil beyond nutrients? Well, we know that organic fertilizers are high in organic matter, which means that they're going to improve things like cation exchange capacity and water holding capacity of your soil. 2 things that can be beneficial. Why would plants growing in a soil with high pH be iron deficient? Again, I know we keep covering this, but we're going to just drive it home. As the pH goes up, iron becomes what? More available or less available? So as the pH increases, iron becomes more or less available? Well, it becomes less available. So if your soil pH is too high, your plant could show signs of iron deficiency. This is why I always say if you think you have an iron deficiency, the first thing you check is your soil pH. Don't just start adding iron, because if you add iron and then at a later date you realize, oh, my pH is high, and then you lower it, suddenly you have iron toxicity. So be very careful about that. List advantages and disadvantages of organic fertilizers. Well, some of this has been already discussed. Things like organic fertilizers improve cation exchange capacity and water holding capacity. Disadvantages. Some of the disadvantages would be the farmer has less control over what nutrients are available to their plants. You can't tailor the fertilizer, so you're limited with what you get in the mixtures. You can try tweaking different components, but it's often very difficult, and so you compromise on certain things. Other disadvantages could be that the nutrients are released at different times. Not all organic fertilizers break down at the exact same rate, which means nutrients become available at different times. There's a question coming later where we'll discuss that a little bit more. Organic fertilizers can also pose health hazards in terms of heavy metals or even just bacteria that are not good for us, so E. coli and Salmonella. So it's important that organic fertilizers are thought through and delivered in a thoughtful way, carefully. Scenario: you've bought a parcel of land in which you are planning on growing market vegetables. Upon taking a soil test, you find that the CEC is a bit low. Upon closer examination, you see the soil is sandy. What can you do to raise the CEC of the soil and increase the water holding capacity? So we've just discussed all this, so it should be popping into your head. You're going to add organic matter. And you could also use organic fertilizers to do that. You could increase your nutrient content and improve cation exchange capacity. But you don't want to overdo your organic fertilizer. You just dole out little bits at a time or you end up overwhelming the soil. So adding compost would be a really good way to improve that soil. Worm castings, probably even better if you can get them. Tropical rainforests are areas of lush growth, but when the forests are cleared for agricultural production, such as corn, yields are good the first year, but decline rapidly each year after the first year. Why? And how could this be reversed? So we discussed this in class with the idea that tropical soils are really weathered because of all the rain that they've experienced over millions of years. Some of the oldest soils on the earth are in tropical climates. And that weathered soil gets finer and finer and has less and less cation exchange capacity. And so as a result, the nutrients are leached out. Now, normally a tropical rainforest looks very lush and productive, and that's because as plant matter falls to the base of the forest, it's broken down and immediately recycled. So there's very little nutrient loss in a tropical rainforest, and so it maintains itself just fine. It's not spreading and growing over the entire continent, it's maintaining itself. As soon as we clear the forest, we break the cycle of nutrient recycling, and the soil can't hold the nutrients any longer, and so as the rain comes, those nutrients are leached away and lost, and so the farm productivity decreases rapidly. So again, biochar is a really good example of how we can fix that. Compost, adding organic matter also would make a difference. List 2 ways nutrients can be lost from soil. This is sort of one of those trick questions, right? We just talked about nutrients being lost because of leaching. We talked earlier about how nutrients can be lost if the soil is too wet and bacteria denitrify the nutrients in like nitrogen and it evaporates out of the soil as nitrogen gas. But there's a third, more obvious one, which sometimes we forget. And what is that? Plants consume the nutrients and remove them. I didn't say leach, I just said lost or gone, right? So remember that. Nutrients disappear because plants are using them. You know, if you're growing in the same garden over and over again and you're pushing the yields as much as you can and you're not doing anything to replenish the soil, you will run into reduced yields and disease problems. List the benefits of adding vermiculite to soilless media. So remember, vermiculite is a sort of a spongy accordion-shaped structure based on rocks that have been baked at very high temperature. The spongy-like structure means that it will also absorb water. So it will improve the water-holding capacity of the soil. And another feature that vermiculite adds is some cation exchange capacity because those layers have lots of negative charges in them, which helps the soilless media store nutrients a little more effectively. In the class, we talked about dribbling vermiculite over top of seeds to maintain humidity while the seeds germinate, and also block light for those seeds that don't want light to germinate. Some seeds need light to germinate, like lettuce, but a lot of seeds, they prefer to be buried in the soil, so they have photosensors to make sure that they're not on the surface, but that they're below the surface, and only then they will germinate. So vermiculite is a really good way to achieve two things, right? Keep the moisture levels constant without you having to water all the time, and block out the light. All right, write out a decision key for identifying a potassium deficiency. So first off, you identify, is it mobile or immobile? And we know that potassium is a mobile nutrient, so we're going to start off by saying symptoms will be in the lower leaves because it is a mobile nutrient. All right, simple. Next one, You're going to say your older leaves will begin to yellow on the edges, which will turn later to necrosis on the edges, progressing towards the center of the leaf. That would be a sufficient potassium deficiency description. Where would a plant get a mobile nutrient if it is in short supply in the soil? We just covered this, right? Where would a plant get a mobile nutrient if it is in short supply in the soil? Well, that means it's not coming up the vasculature from the roots, which means if it's mobile, the plant can actually take the nutrients out from lower leaves and reallocate it to the growing tip, just like the potassium deficiency we just discussed. So mobile nutrients can be removed from older leaves lower down. Lower leaves are less efficient. They haven't got as much light. The plant can afford to lose them to maintain growth at the top so they can get higher where there might be more light, right? So you have to think like a plant. Okay, how does soil moisture affect nitrogen content in soil? Again, this is reviewing stuff, right? We talked about wet soils. If the soil gets too wet, denitrifying bacteria become dominant, and they actually consume the nitrogen and convert it into gas like ammonia or nitrogen, which evaporates out of the soil, and it's gone. So if you're overwatering your plants all the time and you're going through lots of fertilizer, you're actually just feeding bacteria, which are converting those nutrients into gases, which are lost. Other nutrients like potassium would just begin to accumulate in your soil, and the salt levels would increase to the point where your roots would be damaged. So making sure you don't overwater is absolutely critical. All right, list 3 desirable qualities for a soilless media. All right, when in that class we talked about quite a few things. I'll just highlight a couple. One of the nice things about soilless media is that it's consistent and predictable. For a lot of commercial growers, this is critical if you're going to have a uniform crop. Next, it's sterile. We need to know what we're starting with so there aren't diseases present that we don't know about. So it's consistent, it's sterile. It also has a really good balance between water holding capacity and aeration capacity, right? So the idea that it can hold both water and air. So we're going to get optimal root growth. It has cation exchange capacity, which means that the soil will hold on to some nutrients, so not everything is lost. And it can also support organic life, which means you can add beneficial fungi, beneficial bacteria. We talked about mycorrhizae. Those sorts of things can be added to soilless media. They can also support the life of beneficial organisms, which would prevent disease in the roots. So quite a few benefits to soilless media. That's why a lot of growers use it. Why is adding partially decomposed plant matter to soil not a good practice? Again, we've covered this a bit. We did in the beginning of the term, but it was also discussed in the second half, so it's relevant. If it's partially decomposed, that means it is still decomposing, right? Which means that it's going to consume, or the microorganisms that are breaking it down are going to consume some of the other nutrients around, like nitrogen, in the process of breaking down that matter. So partially decomposed plant matter actually will rob your soil of nutrients that otherwise your plants would have access to. So throwing your kitchen scraps in your garden directly is not necessarily a good idea. You're better off putting them in the compost and then taking them out of that once it's done and putting that in your garden. Why are organic fertilizers considered slow release fertilizers? So we talked about this further up. The idea is that they take time to break down because the mineralization process is taking place over a matter of days and weeks, depending on the fertilizer. So it's slow release in the sense that you add it and it will release nutrients to the roots over time as it's mineralized. What happens to soil when lime is added? So again, further up, we discussed the idea that it consumes protons, which means it raises the pH. Also adds calcium. Remember I talked about how calcium is a large atom and it gets in between the soil particles and opens them up. I use the example of drilling a hole in clay with a drill, and the idea is that adding calcium opens up the clay so the water can drain. So adding lime improves your soil's porosity and raises the pH. And not to mention adds calcium, which of course plants need. So there's 3 real benefits to the soil from adding lime. Now, if your soil already has a high pH and you add lime, you don't want to do that. Maybe you want to add something like gypsum instead, which is not going to consume protons as much. When combining various organic fertilizers, what key properties should be carefully matched? All right, this is going back to this question, right? So the idea is if you're adding 3 different ingredients to achieve the nutrients that your plants need for proper growth, the most important property to match is the rate at which they decompose. So if you take something that takes a long time to degrade for, say, your potassium or your nitrogen, and you add something that's very quick to degrade for your phosphorus, your plants are going to have lots of phosphorus, but it's going to take a long time until they have nitrogen and potassium, which means they're going to be experiencing deficiencies for quite a while. So you need to match the speed with which they release their nutrients. There's a list. There's a bunch of information on that class with organic fertilizers and some links to pages where they help farmers make informed decisions about which nutrients to match for what rates of nutrient release. All right, that brings me to the end. Go through these questions again on your own, and hopefully you will be prepared for the final exam. All right. Typically, our final exam draws from the review questions and the quiz questions. So if you're at all curious about what you're going to experience in the exam, this is it. This list of questions is posted on the last week's folder. All right. Take care.